Hi, everyone, and welcome to our first chapter for the data structures and algorithm. So for this chapter, we will be talking about introduction to data structures and algorithm. Okay, so without further ado, let's talk about next slide, algorithm. Okay, so some of you might not really familiar with the term, no, with the word algorithm, but it is just a well-defined computational procedure. Okay, I believe you know what a procedure is all about. That takes some value or set of values as input and produces some value or set of values as output. Okay, so as a simple definition, it is a sequence of computational steps that transforms the input into output. So when we say about algorithm, it is just a step-by-step process. Okay? So para when you heard about it, when you heard about algorithm, this word dili ta maignorante kung unsa siya about. Okay? So let us see if an example, a real world example, you want to cook something or you want to cook a fish, okay? Magluto kag isda. Okay? Ang imong gusto ma-produce na output is pinirito na isda. Okay? So what are you going to do first? Of course, unsay mga different steps in order for you to come up with the piniritong isda. Okay? So unsay mong pinakauna buhaton? Of course, you buy a fish. And then after buying a fish, hugasan ang isda. After paghugas, hinluan, no? Sabay na sa paghugas, hinluan. After paghinlo, um, hinluan ang kalha na sad in order for you to para mag-start nakagluto sa isda. So something like this step-by-step process in order for you um, to come up an output. So in programming, when you develop a system later on, of course, dili man ka basta-basta lang maka-develop og isa ka system, sorry, without any steps ng imong buhaton. So there is an algorithm by that, okay? And yeah, as a programmer, of course, dapat dili ta ma-ignorante kung unsa ni siyang term, unsa ni siyang mga word. So again, algorithm is a step-by-step or computational steps that transform the input into output. So I hope that you understand the word, no? Dali ra siya masabtan. Okay, next. Okay, data structures. What is a data structure? What is a data? What is a structure? Okay, so when we say about data structure, it is a way to store and organize data in order to facilitate access and modifications, or no single data structure. Yeah. So when you heard about data structure, it is a way on how are you going to store and organize your data. So let us say, for example, you developed a very big system. Okay, of course, in a very big system, there is thousands, billions of data. Think about Facebook. If your data are not structured, no, kung wala na siya na structure, then what will going to happen to your system? It will, when you search about someone, maybe your system will going to crash, or your system will not really produce the things that you wanted to, something like that, if your data are not structured. Okay, so again, when we say about data structure, it is your way on how are you going to store and how are you going to organize the data in order to facilitate access and of course to become more efficient when you are going to use it. Okay, so dapat dili tayo ignorante when we talk about data structures. From the root words itself, data structures. How are you structure your data? How are you going to store your data and organize your data? Okay, so I hope that's really understandable. No single data structure works well for all purposes, and so it is important to know the strengths and limitations of several of them. So of course, in the next chapters, when we have a lot of examples later on, you will understand more about why data structures is important. Okay, why it is always be like data structures and algorithm. Anong permina sila mag-uban. Okay? So much for that. I hope you understand what a data structure is all about. And yeah, so following terms are the foundation terms of a data structure. So of course, naay mga different foundation when it comes to data structure. No, first is the interface. The interface, each data structure has an interface. Interface, it represents the set of operations that the data structure supports. An interface only provides the list of supported operations, type of parameters they can accept, and return type of these operations. So we're going to learn that more when we start, when we start doing some code, no? Makita ninyo what is a parameter. As of the moment, dili pa kanimo siya masabtan, no? What are the different operations? Huh? What are the different what are the different return types of these operations that we use? Okay, so later on, when we start coding, as what I have said, we'll understand that the data structure has always an interface and, of course, an implementation. Okay, when we say implementation, it provides the internal representation of a data structure. It also provides the definition of the algorithms used in the operations of the data structure. So let us say, for example, I'm going to give you a problem wherein it will calculate, or it will calculate the value or the sum of two integers. Okay, let us say ingon ana. Let us say 1 plus 1, 1 plus 2. Akong iatag na example sa inyo ah. How are you going to do that? How are you going to structure your data, and how are you going to create an algorithm for that? A step-by-step process in order for it to provide an output. Okay? Yun ana. So there is in a data structure, there is an interface and there is an implementation. Okay? Muna siya ang foundation. Muna siya pinaka-important. Okay? Next. So guys, as for this chapter, ano lang kita, we're going to talk about more what a data structure and algorithm is all about. Okay? And then proceeding to sa coding later on. So what are the different characteristics of a data structure? First, correctness. Okay, and data structure implementation should implement its interface correctly. Dapat sakto, of course. Time complexity. Running time or the execution time of operations of data structure must be as small as possible. Okay, think about it, guys, when you have this big system, as what I have said earlier, when you have this big system and then um, a user wants to search an item or something like that, how are you going to structure your data na mas dali nga makita ni user ang yang gusto pangitaon? Okay? So in a characteristic of a data structure, time complexity must be small as possible. Dapat mas dali ra niya ma-render, no? Kay if taas kayo ang time, sige, taas kayo ang time, no, na pagkuha o pag-get sa data, then what will going to happen, no? Dapat kabalo na mo, di ba? Kung ikaw kaya naka-search or something like nakay gusto buhaton tapos dugay kayo, di ba di kaganahan? So that is the time complexity. Again, first one is the correctness. It should be implemented correctly, and your data structure should always be as small. The time complexity should always be small as possible. And we also have this space complexity. Okay, very important that you should consider the memory usage of the data structure operation should be as little as possible. Okay, so later on when we do the coding, it's very important that you should know um, if you're going to use integers, if you're going to use floats, doubles, etc., what kind of data types are you going to use, and how are you going to really structure your data, you should always consider the memory usage. Okay, we're going to talk that later on pag start na jud tag nanatay mga sample codes. So that's very important that your data structure should be correct, implemented correctly, and it should be the time complexity should be small as possible, and the space complexity should always be as little as possible. Okay, So bear that in your mind that when you create programs for your system, when you create solutions to your program, it should run as fast as possible. Sorry about that. And then it will, it must take only little memory as possible. Okay, as little as possible. So that's the characteristics of a data structure. Next, we have this called execution time cases. Okay, execution time cases is when you're okay. Let us say, for example, you already have structured your data, and you are now going to execute your program. So there are three cases which are usually used to compare various data structures execution time in a relative manner. We have first is natin ginatawag na worst case. Worst case scenario, no, worst case, pinaka-worst. This scenario where a particular data structure operation takes maximum time it can take. If an operation's worst case time is, let us say, function of n, then this operation will not take more than the function of n time, where function of n represents, I know, where f of n represents function of n. Okay, so let us say, for example, the maximum time you set is the execution should only take 10 seconds. But then, ang yung execution, niabot siya og 50 seconds. No? So, nilapas siya sa maximum time nga imong giset, which is the worst case. The average case is it is depicting the average execution time of an operation of a data structure. Nasa average lang siya. So let us say, for example, in an operation takes function of n time in execution, then m operations will take m function of n time. Or a simple definition para mas daliin nyo siya masabdan, when you are expecting na this code will take 10 seconds, no? 10 seconds to execute, and then pag execute na nimo, nakita nimo nga average time, let us say naa sa mga 15, no? Ano, it's the maximum na sa mga 8, or na sa mga 7 seconds lang inyong pag-execute, then something like that, not just average, or 5, some inana. The best case is depicting the least possible execution time. Let us say, for example, you are expecting na I think this kind of code sa iyang kataas, no, sa imong pagbuhat sa iya will execute up to 20 seconds. But as you executed it, it only returns around 5 seconds until the execution is done, which is that is the best case. Okay, again, as what I have told you, one of the characteristic in a data structure should be as fast as possible, and of course, yeah, so that is the best case kung ang gamay ra gid ang iyang time nga ma-consume, paspas ang imo ang pag-execute sa imo ang program. Okay, next, let's move on to why do you have to learn data structure and algorithm? Nganong kailangan man nimo siya? Okay, you might not galibog pa man mo karon, or di pa makainyo siya masabtan, but I just like to give you some insights why you really need to study about this one. Dili kay as a programmer magpataka na lang pataka na lang ka og program dara balag ingon ana, but without knowing anything about how are you going to structure your data, how are you going to do the algorithm for that one. Okay, that's a very bad, because you know what, and kung inana imong panghuna-una, kung dili ka kabalo sa how are you going to structure it, how are you going to do the algorithm, then I'm telling you, the success rate of your application or your system may be 0.01. No? So it's very important that you should know how are you going to do it correctly in an organized manner. And yeah, so as an application are getting complex and data rich, there are common three problem application face nowadays. First is the data search. Okay, so consider an inventory of 1 million item of a store. I hope I believe you guys is familiar with the different online stores nowadays. So if the application is to search an item, it has to search an item in a 1 million items, very time slowing down the search. As data grows, search will become slower. Okay? So muna siya ang one of the problem nowadays. If we don't know how to structure our data, we don't know if we define the algorithms correctly or the data structure correctly, wala na to be follow katubi daw ang three characteristics of a data structure on how are you going to code it. That will be one of the main problem. Okay, let us say I know you're familiar with Shopee. Nag login ka, nag-search kag item, dugay kayo nagpakita si item, no? Because wala kayo na structure and data, kay dagan na kay billions and billions and data dito. So that's one of the problem nga kailangan na tumabalan si data structure and algorithm. Why you need to learn. Next, the processor speed. Okay, the processor speed, although being very high, falls limited if the data grows to billion records. It will going to burn down your processor kung wala gid na nimo siya naayuhan. Okay, so it's very important nga we know the different characteristics, di ba, as what I have told you earlier, para refrain ni siya ng mga scenarios. Okay, and then we also have multiple requests. Of course, there are billions of users, thousands of users can search data simultaneously on your server. Even the fast server fails, well, even the fast server fails while searching the data. Okay, so consider your application to be being able to access with millions, no, with thousands of users every single minute. No, not just hour, not just a day, but every single minute they can kayo request. So yeah, there are multiple requests. So if you haven't structured your data correctly, and you haven't defined the algorithms correctly when doing or when yeah when doing the different procedures for your system, then possible nga imo ni siyang um, mga different problems. Okay, so to solve the above mentioned problems, data structures come to rescue. Data can be organized in the data structure in such a way that all items may be required to be searched, and the required data can be searched almost instantly. But of course, you might asking yourself right now, how, how, unsaon siya? But don't worry about that because there are a lot of, data structure and how are we going to do that? How are you going to sort, to search, to delete, edit, and a lot more. So I hope that you guys get some idea on how and why do you need to learn about the data structures and algorithm. Okay, next, the applications. So we're going to talk a little bit more in the next chapter about the different applications. But as for now, is to give you some insights about this one. The applications of data structure and algorithms is of course search, when you want to search an item, or sort when you want to sort in a certain sort items in a certain order, and of course when you want to insert, update, and delete. When we say insert, we want to insert an item. When you want to update an existing item, and delete is to delete an existing item. Okay. Um, yeah, going to provide a lot of examples later on. So that's the applications of the data structure and algorithm. Search, sort, insert, update, and delete. Next. Okay, please familiarize yourself with the basic terminology. When we say data, these are the values or set of values. Okay, again in programming, data are the values or the set of values. When we say data item, this refers to a single unit of values. In group items, these are divided into the data items are divided into sub items, and that sub items is called group items. Okay, so you have this data item are divided into sub items, and then that is the group items. We also have this elementary items. Elementary items this cannot be divided, the data items that cannot be divided. Again, guys, we're going to understand the inertia later on if we will start creating our data structure. But for now, just ano lang, familiarize yourself. Okay, when we say attribute and entity, I think other course are more. I think other courses attribute an entity sa inyong data structure. I don't know, sa inyo ang database. Yeah, I think it's database. I forgot. Yeah, sa database ninyo na subject is you're going to define more about attribute and entity. Okay, entity, it contains certain attributes or properties which may be assigned values. Okay, so as for this one, to give you just a little insight about an entity and attribute is, let us say you as a person, you are the entity. What are your attributes? No, the color of your skin, the color of your eye, the color of your hair, something like that. So the entity set, these are the set of entity. Okay, these entities of similar attributes, and then field in programming, it is a single elementary unit. When we say elementary unit, again, these items that cannot be divided. And yeah, and record is a collection of field values of a given entity, and file is a collection of records of the entities in a given entity set. So medyo lisod po siya sabton because you don't have any idea yet on how are you going to structure data, but just familiarize yourself kay kailangan ninyo sa mabalan what a data is all about, what a data item is, what it is entity, entity set, field, record, file, attribute and entity, and then elementary items. Okay, so those are the basic terminologies. Next. Okay, let's talk more about algorithm. So again, as what I have told you, it is a step-by-step process or a sequence of computational steps that transforms input into output. It is a step-by-step process. Okay. So from the data structure point of view, following are some important categories. So this can be used in search. Now, when you want to search an item, sort, insert, update, and delete. Ayun. Next, what are the different characteristics of an algorithm? Okay, so again, guys, ako ginising ibalik-balik, I'm going to repeat myself over and over again. It is a step-by-step process, okay, to provide an output. Okay, let us say, for example, I want you to create a program that will display the even or odd numbers, something like that. Okay, what is the algorithm that you're going to do? Okay, so what are the different characteristics of algorithm? It should be unambiguous. When we say unambiguous, it should be clear and unambiguous. Each of the steps or phases and their inputs or outputs should be clear and must lead to only one meaning. Okay, dapat dili siya libog. Dapat dali ra siya masabtan. Okay? Next is the input. Input should have 0 or more well-defined inputs. Of course, naapod tayo output. If you have input, you also have output. This should have one or more well-defined outputs and should match the desired output. Okay, let us say create a program that will display the sum of two numbers. So your input, of course, the A and B, the first number and the second number, and your output is the sum of the first number and second number. So 1 plus 1 is equal to 2. The output is 2, something like that. Next, your algorithm should be finite. No? It should terminate after a finite number of steps. Dili siya dapat infinite. Dapat na kay steps kung kano siya nagigay step kung kano siya stop. Okay? So, yeah, na ending dapat. Dapat walay forever. Okay? So when we talk about algorithm, kailangan na siya finite number of steps. And of course, feasibility, feasible from the term, from the root word itself, feasible. No? It should be feasible with all the available resources and independent. Should have a step-by-step directions, which should be independent of any programming code. So bisan pag bisan unsa pa na programming language ang mong gigamit, it should be independent. So your algorithm can be used sa Java, can be used sa Python, can be used in C, in C++, or any other programming language. Okay? It should be independent. Yun. Dili kay kung nagbuhat kag algorithm para sa ani nga program, para ani ra gid siya nga program. Dili siya inana. So that's a wrong one. Okay, it should be independent. Dapat dili magmatter ang programming knowledge kay no, the programming language kay imong gigamit para yeah, para magamit siya independent. Okay? Next is how to write. Okay, so how to write an algorithm? There are no well-defined standards for writing algorithms. Okay, and rather it is a problem and resource dependent. Again, it is a problem and resource dependent. It depends on your problem, kung sa kung gihatag nga problem sa inyo, and of course the resource no nga gamiton. Algorithms are never written to support a particular programming code. So, munda kung ginaingong gibalik-balik sa inyo, it should be independent. As we know that all programming language share basic code constructs like do, for, while, or flow control, if, else. So, tanan programming languages, nagi mga do, for, while, or if, else, if, else, kana sila, na mga flow control statements. So, these common constructs can be used to write an algorithm. Kaya pwede nimo siya magamit because all programming languages, sorry about that, ganun kakasave ko sa knowledge and language. Kay mao na sila ang pinaka-basic. So I think you also have your programming na subject, which you will going to discuss more about these terms, no, para mas pasabtan ninyo. And yeah, this common constructs can be used to write an algorithm. So we write algorithms in a step-by-step manner. Again, step-by-step manner. But it is not always the case because there are times nga again, our goal is to make it um, easy as possible and then mas shorter as possible. Okay? But well-defined siya, unambiguous, okay? And algorithm writing is a process and is executed after the problem domain is well-defined. Of course, nagi kay problem kay saan mo pag-write? No, bisa ka algorithm if you don't have a well-defined problem. That is, we should know the problem domain for which we are designing a solution. Okay, let us say, for example, yeah, as what I have said earlier, a program that we're going to display the sum of three numbers, two numbers, four numbers. There should be a specific problem for that. So of course, in the next chapters, there are a lot of examples that I'll be going to give to you, and of course, some exercises in order for you to learn how to do an algorithm correctly. Okay, so next. Oh, balik siya. Think. Let me how to write that. Let me delete this one. Okay, here's an example. Example. Okay. Design an algorithm to add two numbers and display the result. Okay, step one, you need to start. Of course, start step one, diba? And step two is what are the different items? What are the different data needed for this problem? We have two numbers. Okay, so we should define or declare your first number, second number, and third number. Or you could say declare three integers. So for this one, this will not as kanina steps, ayan display lang is the integer. So the result should be an integer also. Okay, so integer A, B, and C. The C is the result. Okay, so the A is the input. Again, two numbers man siya. B is the input and C is the output. And then after that one, after declaring three integers, or these are your variables, you define what are the values of A and B. Okay, define the values of A and B, and then add the values of A and B. Then store output of step 4, the values of A and B to C. Then print C. Then stop. Okay? So as you can see, Kanisha, it does not, it is not dependent to any programming language. Di ba nakita niyo siya dara? It's not written in Java. It's not written in Python. It's not written in C. So you just define, you're just going to define what will going to happen when you create an algorithm to some problem. Okay, and then always remember guys na mag start gina siya sugod and then stop. So again, as what I have said, dapat finite numbers should not be infinite. Okay, and when also creating algorithm, it's not necessary yung butaan pa ni masyag step numbers. It's good. It depends on you. If you want to add numbers, it's also good if wala numbers. It depends on you. Okay, pwede rang wala number, pwede na number. Okay, as you can see in here, we have, wait, okay. Yeah. So algorithm tell the programmers how to code the program. So that's why you need to define the different steps. You need to create the algorithms in order for the program, in order for you, not as the future programmers, how are you going to code it using using the language that you're going to use? So alternatively, the algorithm can be written as step 1, start at, get the values of A and B. This one is much easier, right? And then C, store the values, store the result of A plus B values to C, and then display the result, then stop. Okay, that can be written as tama lang siya sa 5 steps. So in design and analysis of algorithm, usually the second method is used, this one, to describe an algorithm. It makes it easy for the analyst to analyze the algorithm, ignoring all unwanted definitions. He can observe what operations are being used and how the process is flowing. Okay? Something there is a first is, as you can see, ang yang gipambuhat is declare three integers, define values. There is a second, ang yung gibuhat is automatic na, no? Start add, you get the values of A and B, then store the result to C, then display C. Okay? So di ba mas dali siya sabton, mas gamay ra siya ang steps, mas dali siya masabton, and then it's fast. Why? From the previous one, 7 steps, dire 5 steps ra in the second one. Okay? So again, you go back to the characteristics and you go back to how to write the characteristics of the algorithm. And yeah, when we say algorithm analysis, the efficiency of an algorithm can be analyzed of two different stages: before implementation and after implementation. Okay, a priori analysis is theoretical analysis of an algorithm. Efficiency of an algorithm is measured by assuming that all other factors, for example, processor speed are constant and have no effect on the implementation. So it's a theoretical analysis of an algorithm. That is the priori analysis. Assuming, no, ga-assume ka nga dili you are creating this data structure, no, na dili maapektuhan ang processor speed. So you are assuming that all other fixtures work as expected. When we say posterior analysis, it is empirical. Now, empirical analysis of algorithm. The selected algorithm is implemented using programming language. This is then executed on a target computer machine. In this analysis, actual statistics like running time and space required are collected. Okay, the posterior analysis is imo na gid siyang i-execute na gid nimo siya gamit ang programming language kay imong gamiton. Let us say, for example, you use Java, you use Python, and you use C, you run all the code kay imong gibuhat, you run the structure, kay na structure nimo imong data, you execute it. Of course, sa imong pag-execute, nakikita nimo dito ang mga actual statistics like the running time and the space required for that kind of data structure. Okay, so that is the algorithm analysis. Next, okay, algorithm complexity. So there is a complexity. Suppose X is an algorithm and N is the size of input data. The time and space used by the algorithm are the two main factors which decide the efficiency of X. First, algorithm complexity, time factor. Okay, time is measured by counting the number of key operations such as comparisons in the sorting algorithm. So it's very important that you should consider the time factor. The space factor. Space is measured by counting the maximum memory space required by the algorithm. That's why I'm telling you over and over again that when you create when you structure your data, when you create an algorithm, you should consider the time, no, on how much time will it take in order for your program to execute, space, the memory allocation, okay, the maximum memory space required by the algorithm. So the complexity of algorithm, that would be function of n, gives the running time and or the storage space required by the algorithm in terms of n as the size of the input data. Okay, ayun, that's the algorithm complexity. So you must consider the time and space. Okay, when we say space complexity, it is an algorithm. It represents the amount of memory space required by the algorithm in its life cycle. So the space required by an algorithm is equal to the sum of the following two components. We have this first, a fixed part. This is a space required to store certain data and variables that are independent of the size of the problem. So for example, simple variables and constants used, program size, and etc. So in a space complexity, in defining your algorithm, there is fixed part. Fixed part again is fixed, now such as the data and the variable. So let us say an integer has a fixed space, double has a fixed space, an array, etc. Blah blah blah. So sorry, it's a variable part, okay? And double float, character, and a lot of data types out there, okay? So we're going to learn that in the next chapters. The variable part is required by the variables. Is space required by a variables whose size depends on the size of the problem. Okay, so for example, dynamic memory allocation, recursion stack space, and etc. So in a space complexity, we have fixed, we also have variable. The fixed ang iyang size. The variable, dynamic ang iyang size. Depends on the size of the problem. So in an algorithm, again, natay, the complexity, the analysis, the complexity, and then the space complexity. Oh, okay. So this is an example. The space complexity of any algorithm P is S function of P is equal to the C plus the SPI, where C is the fixed part, and then the SI is the variable part of the algorithm, okay? Which depends on the instance characteristic. Let's take a look at this example. A problem that we're going to display the sum of a and the first number and second number. The step one is to start. Step two is a plus b plus 10 is the result of c and then stop. So in here we have three variables, that is a, b, and c, and one constant. Okay, hence s of p is equal to 1 plus 3 now. Okay, now space depends on the data types of given variables. It depends kana si a and b depends na ang yang space sa kung unsa imong gihatag nga value sa iya. The constant types and it will be multiplied accordingly. It depends. Sa kana si 10, that is your fixed space, di ba? Hindi naman siya ma-change. Static value man siya. Pero kung dynamic, kung nag-assign lang kag variable and then dynamic ang iyang values, then that's the time na dynamic po ang iyang space na kwaon. Okay, you don't know how much space we're going to get. And time complexity, of course, it represents the amount of time required with the algorithm to run to completion. It is the time requirements can be defined as the numerical function of t of n, where t of n can be measured as the number of steps, provided each step consumes constant time. So for example, adding of two n-bit integers takes n steps. Consequently, the total computational time is t of n is equal to the c multiplied by n, where c is the time taken for the addition of two bits. Here we observe that t of n grows linearly as the input size increases. Okay, so in an algorithm, time should always be considered as again and again, as what I have told you, it should be as little as possible, as fast as possible. So you should be very careful when defining your data types correctly. Kung you must use your data types kung para-asa lang din siya, and then the inputs and then the values, the data that you're using for your structure, for the data structure. Okay. And okay, so that's all for the algorithms. I hope you guys have learned something. Next is the local environment setup. So before we proceed with the samples on running a program, no, I'll be giving you some programs that, yeah, and examples. You should install Python as we will be using Python. Okay, so to install Python, just go to python.org, and then there's a download button in there, then install. Make sure to actually add Python 3.9 to the path. Okay, and then yeah, install the Python. After installing the Python, you're going to see this. There's a documentation, there is an IDLE. Yeah, the IDLE, guys, is that one is used by Python as the interactive development learning, yeah, learning environment. I think it is where you can code, right? This, yeah, an IDLE, but it's up to you if you're going to use the default IDLE of Python. But for me, I'd like you to install PyCharm. This is an IDE for Python, and yeah, for Python developers. This again, it is an interactive development environment where we can code using Python. But it's okay if you don't want to install PyCharm. There are a lot of other IDEs out there. But for me, on my examples, I will be using PyCharm. Sorry about that. Okay. So to install the PyCharm, just go to PyCharm, and then just download the free open source, this one community. Yeah, for pure Python development. Okay, so I think that's all for this video. Okay, so that's all for the chapter 1 introduction to data structures and algorithms. So I hope you guys have learned something. Take a look at the next video because we will be learning about I think the next topic, I think the next topic is insertion sort or list. Okay, we're going to talk about that. Ayun. So that's all for this video. Thank you so much for watching, and I hope you guys have learned something about the introduction of the data structure and algorithm. I know kabalo na mo just algorithm. It is a step-by-step process, and then the data structure. It is how you store or organize your data for efficient access or modification. So that's all for this video. Thank you and God bless you guys. Goodbye and have a nice day.